Order of operations are important for us to remember, because when we solve equations, we might have to simplify an equation, or when we do later on in our chapter or in our unit, when we cover polynomials, we might need to know what operation to do first. So let's just go over these for a minute. Most of you remember the acronym, Please Excuse My Dear Aunt Sally, where the P is for parentheses, excuse is for exponents, my dear stands for multiplication and division, Aunt Sally is addition and subtraction. Be aware that when we multiply and divide, we can do either one of those first, as long as we're doing it in the order they appear from left to right, just the way that we read. Same thing for addition and subtraction. We want to perform those operations in the order that they appear from left to right. Okay, let's go over first, though, exponents. If I had, for example, -3 raised to the second power, writing something as an exponent is a shorthand form of writing repeated multiplication. This is really saying -3 times -3, because I'm doing it twice, and I know that that's +9. However, this right here, because there are no parentheses around the -3, all I'm raising is this +3 to the second power. What this really says is I have a -1, that's this part, times 3 times 3. That's actually, 3 times 3 is 9, times -1, -9. Notice that these are not the same. Those parentheses back here that told me what I was squaring made a huge difference. We can kind of relate that to this concept. Remember a few lectures ago we talked about the absolute value of something is really the distance away from 0. So if I wanted to say the absolute value of -4/5, that would be 4/5. But I have this pesky little negative sign hanging out on the outside, which is really almost multiplication. I am multiplying a -1 times that. So the answer would be -4/5. This -4/5 came about because I had to multiply by the negative sign on the outside. So we treat absolute value signs almost as parentheses. We have to evaluate what's in the parentheses before we can multiply or divide. These three concepts right here lead to a lot of frustration if you don't really think about, or if you don't really understand the processes of the order of operations. So in other words, I'm kind of trying to warn you, be careful, because there are common mistakes, in other words. Okay, straight order of operations. Here we have an example, -2 minus 4 squared. All of that's over 3 times -6. The fraction bar that's right here, we count that as division, but it kind of separates this into two problems. I need to do what's in the numerator before I can, and then I simplify the numerator, I simplify the denominator, and then I do the division. So this is really going to look like -2 minus 4 squared, because that square is for that 4, which would be 16. All of that's over 3 times -6, which is a -18. Here I have -2 minus 16. Remember, this is change. So I end up with -18 over -18. Now I can divide, which gives me a +1. Let's try that again. Here I have something in the numerator and something in the denominator, but I need to simplify these first. Multiplication comes before just the addition. So 4 times -3 is -12 plus -8 divided by 2 plus -2. Remember, if I have opposite signs, I'm really going to subtract, so that becomes 0. Negative 12 plus negative 8, if my signs are the same, we're going to add. That would be 20. Take the sign common to both. Negative 20 over, not 2, negative 20 over 0. Can't have it. I can't have it because 0 is in the denominator. So in other words, this is undefined. Do not forget, we cannot have 0 in the denominator. My answer is undefined. Okay, now let's look at properties of real numbers. We have 1, 2, 3, 4, 5 properties listed here. These are properties that we use all the time in solving equations, simplifying things. You use them, you just probably don't always associate a name with them. So let's kind of put some numbers with it. Here we have the commutative property. Commutative property means order, changing the order. So if I have A plus B, I can rewrite that as B plus A, and I never did anything to it. So let's say I had 3 plus 5. If I rewrote that as 5 plus 3, I still am going to get the same answer because 3 plus 5 is 8. 5 plus 3 is 8. So just changing the order didn't do anything. This also applies for multiplication. Notice this was addition, here's multiplication. What if I had 3 times 5 and 5 times 3? Well, I know that 15 is still equal to 15. So changing the order on multiplication or addition doesn't change my problem. I challenge you to decide whether subtraction is commutative. Is subtraction commutative? So think about that for just a second. The answer to that would be no. It is not commutative. Let's say, for example, I had negative 3 plus 5, and I rewrote that as 5 plus negative, no wait. Let's say I had 3 minus 5. Is that the same as 5 minus 3? Okay, no, it's not, because I would have to change, and I know that 3 plus negative 5 is negative 2, and 5 minus 3 is a positive 2. These are not the same, so subtraction is not commutative. Okay, the associative property. The associative property, we can think of this as grouping. Okay, in other words, if I grouped this and added that, I can reorder what I'm grouping and still come out with the same answer. So let's plug some real numbers here. If I said 3 plus 5 plus 2 is equal to 3 plus 5 plus 2. Let's see, does that work? Well, 3 plus 5 is 8 plus 2. And this side I have 3 plus 7. 5 plus 2 is 7. Well, 8 plus 2 is 10. And yes, 3 plus 7 is 10. 10. So yes, that works. With addition. Let's try it for multiplication. Here I have 3 times 5 times 2, or I could have 3 times 5 times 2. Well, 3 times 5 is 15 times 2, and 3 times 5 times 2 is 10. 30 is equal to 30. Yes, it works. You'll find that these properties hold true for addition and multiplication, and they don't hold true for subtraction and subtraction and division. Okay, another property that we have is called the additive inverse. This is basically just saying if I have a number and I add the opposite of that number, I get 0. Let's say I had 3 plus negative 3. Well, 3 plus negative 3, yeah, that's equal to 0. That's called the additive inverse, and we use this all the time when we solve equations. We also use the multiplicative inverse. It says if I multiply a number by that number's reciprocal, which is that number over 1, then I get back 1. Let's say I had 3 times the reciprocal of 3 is 1 over 3. Well, our rules for multiplying fractions say I can change my whole number to a fraction, and I can cancel before I ever multiply. So yes, I get back 1. So the addition and the multiplicative inverses help us solve equations. I bet you didn't know that's what those were called. Okay, now we want to talk about the distributive property, a very, very important property throughout the rest of our math concepts. It basically just says I can take some number and multiply it by each of these numbers on the inside. So if I had, for example, 3 times 5 plus 2, then that would be equal to, we're going to take the number on the outside and we're going to multiply 3 times 5 and add that to 3 times 2. So let's see if the math really works out on this. Well, over here I have 3 times 5, which is 15 plus 6. 15 plus 6 would be 21. Over here, let's do our order of operations, which tell us that I have to do what's inside of there. I have to do the operation inside of the parentheses before I multiply. So 3 times 7, well, 3 times 7 is 21. So yes, the property is true. And we use the idea that I can multiply and distribute this 3 to each of those terms so I can get rid of these parenthesis signs. That's the goal of the distributive property. I want to go over with you a few more things that, I don't know, they don't really have a category to fit in as far as reviewing is concerned, but we will be using these later on. For example, if I wanted to translate these words into an algebraic expression, this says 1/10. That's pretty easy. Remember the word of means to multiply, so I'm going to represent it like that. And then anytime you have a number, that's where you put x. And let's use y in this case. So in other words, this is 1/10 y. 1/10 of a number. How about the product? That's kind of easy. That means to multiply. Of -2 and t. That's telling me to multiply -2 with t. Okay, and we will come back and really discuss this in greater detail when we get to it in the semester. One more thing, evaluate each expression if this is my given numbers. Really, when you're told to evaluate something, you're going to take these numbers and plug them in. So we can rewrite this as 2 times, and I'm going to rewrite this 5 plus, with parentheses for the numbers that I want to replace. And I think that that's important because sometimes people lose negative and positive signs. So here I say I'm going to multiply 2 times c. I come over here and I find out that c is -2. And I'm going to say 5 plus a. Well, a is -3. So I have 2 times a -2, which is going to give me a -4 over 5 plus -3, which would be +2. So my answer would be -2. Okay, let's do that again over here. I have something minus something over something plus something. B is going to be 4. C is -2. B is 4, and A is -3. Okay, I think the parentheses are important again because it helps you remember and do the correct operation and not forget your negative signs. So here I have to change, and I'm going to end up with 4 plus 2 is 6. 4 plus a negative 3 is 1. So the answer is 6. And last, let's practice this one. I have 3 times something squared minus something cubed. So let's fill in our parentheses. Here I have an a, so I'm going to square my negative 3. Here I have 4, so it's the 4 that's going to be raised to the third power, or the cubed power. So I'm going to say 3 times, what is negative 3 squared? That's positive 9. Minus 4 cubed is actually 64. So I have 27 minus 64. So I have negative 37. Okay, especially when we raise numbers to a power, it is very important to make sure you're raising the whole number that you're replacing. It's easy to drop a sign if you don't separate these numbers using parentheses. And that's how you would evaluate expressions. You can come back to section 1.4 in the book if you need some extra help on that.